Yeah, hi. So in this video, we are going to learn about vectors, okay, how vector diagrams are drawn. Okay, so there is going to be two files for this. One is vector solving, where we were going to solve vector in M1 style, and another one is where we are going to draw the diagrams and find the resultant vectors. Okay, so this is the drawing part we are going to do. Before we do any vectors, the first thing we have to do is something known as, you have to see the diagram. So you can see the diagram over here. Okay, this is the diagram. You can see it's a particle which has an horizontal force of 16 Newton, and it has a 12 Newton, okay, force, but which is 35-degree, okay, anti-clockwise, okay, to from the vertical, okay, 35-degree from the vertical. So it's a 12 Newton force. You can say it's 35-degree from the vertical, or you can say it's 35-degree from the vertical, or is it's 55-degree from the horizontal. You can say that also. It both means the same thing. It's 55-degree from the horizontal. That also you can say. Okay, so the first thing you have to know is you have to do a rough diagram with the help of what we call something known as head to end method, or head to tail method. What does that mean? So first of all, you draw the particle. This is a rough diagram I'm drawing over here. You draw the particle and you choose any one of these forces. You choose any one of these forces. Let's say I chose, they already drew 16 Newton for us. Okay, they already did the 16 Newton for us, so they did 16 Newton for us. Okay, so this is where the diagram ended. This is where the diagram ended, this particular line. So what method did I say? I said it's known as start to end method, or head to tail method. So start to end, money, where the arrow has ended, there you have to start a new arrow. So your new arrow will start from here itself. So which is the only one arrow that is left to us? That is the 12 Newton. Okay, can you see that 12 Newton is 55-degree from the horizontal, or it's 35-degree this way 35-degree from vertical? Okay, so what we can do is we can draw this imaginary vertical line, and we can, from with the help of protractor, we can take 35-degree and we can draw it 12 Newton, let's say. Okay, for 12 Newton we can decide the scale later on. Okay, so this is your start method. It ended over here. From here the new arrow started. See, in this diagram both the arrows started from here. In this diagram it's known as start to end method. Here it ended, from here it started. See, here it is ended, the second arrow started from here itself where the previous arrow ended. Okay, and where is this next arrow? Is 35-degree to the vertical, or 55-degree to the horizontal. If you want, you can take protractor and draw 55-degree from here, or if you want, you can just draw 35-degree from the imaginary vertical line. Later you have to rub this though. Then this is where your your diagram started, and this is where your diagram ended. So join both of them. So this is your resultant force. Okay, so this is a rough diagram. We are going to follow this over here. But the first thing we need to decide, what are the scales, because they have given us the scale over here. As it's very hard to see the number of boxes, we are going to measure it like this. Okay, so according to my calculation, it's around 7.6. So therefore you will write, okay, you are going to write, if 7.6 centimeter is giving me 16 Newton, therefore, see, this is the diagram we are going to draw. This is the line we are going to draw. Therefore, for 12 Newton, how much are we supposed to take? We should do cross multiplication. If we use the calculator, 12 into 7.6, okay, if you see it, it's 12 into 7.6, okay, divided by 16. Divided by 16. So answer is around 5.7 meter. So we are going to take 5.7 meter for him. So it's going to be 5.7, sorry, centimeter. Okay, it's going to be 5.7 centimeter. And what angle is it? It's 35-degree from the vertical, or 55-degree from the horizontal. So here the next arrow is going to start, right? So we will keep our protractor over here. Okay, we are going to keep the protractor over here, and you can take 55-degree from the horizontal if you want to. So take 55-degree from the horizontal, that's somewhere over here. 55-degree from the horizontal. Okay, and now we will take, how much did we decide? This length was 5.7 centimeter. So I'm going to decide 5.7 centimeter over there. So it's 5.7, right? 5.6, 5.7, exactly to the dotted line. Okay, so this is my 5.7. Okay, It's going to be my 5.7. Let me just recorrect it again. Okay, 5.7. Okay, so this is where it's 5.7 is. Okay, now so you see, now we can give an arrow line, but we are not going to write the 5.7 here. We are going to write the 12 Newton here. We are not going to write 5.7. Okay, then this is where the diagram started, this is where the diagram ended. So we are going to join this together. That will be our resultant force. That is going to be our resultant force. So now, and you know, this is where it started, this is where it is ended. So arrow will be, I'm going to put a double arrow to show that it's a resultant force. What did they say? Find the magnitude of the resultant force. Yeah, so that's, I'm now going to help you how to find the magnitude of a resultant force. Okay, first thing, we are going to take its scale. How much is it in terms of centimeter? It's around 6.5 to be exact. So therefore I'm going to write this again. If 7.6 centimeter is giving me 16 Newton, which we already established over here. Okay, so therefore how much did we get over here? 6.5. Now so 6.5 centimeter is going to give me how many Newton? So 7.6, okay, let's see, 6.5 into 16, 6.5 into 16, that's 104, divided by 7.6. so it's coming around 13.7 Newton. So it's around 13.7 Newton. What did they say? Next question. Angle of the resultant force to the 16 Newton force. So this is my resultant force. And how much was it, by the way? 13.7 Newton. So I'm writing 13.7 Newton over here. So angle of the resultant force to the 16 Newton. So this is the angle we are looking for. Okay, let's find what is that angle with the help of protractor. Try to do it as calmly as possible, nothing to hurry over here. Okay, so that's around 40, 45, 46, 47 degree. So it's around 47 degree. Okay, so if anybody needs this file, can take it from me, or you guys can just take it, print out from June 2016 GCE question number 14. Okay, and I'll make another videos later on.